Alright, they have questions for us about relations here, and about whether they're functions is what we're going to end up with. Fortunately, we have this excellent thing called the vertical line test that makes these pretty simple, and the way it works is when you have a curve, you draw vertical lines through it all over the place. And what you're looking for is how many times those lines strike the curve. This one strikes once, 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 and if I keep going, you can see it's going to be once every time. So what that means is for every x value that one of these vertical lines is at, there's only a single y value on the curve. When that happens, we say that our curve is 1 to 1. So that's true for curve A. And that also means curve A gets to be a function. Let's see if that works with relation B. Vertical line once, 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 once. Yep, that one's fine as well. So B is also a function. I haven't missed this middle line. I'm going to come back to it later. These first two are the ones about the function definition, and I think that's the most important thing. We'll talk about the middle bit in a moment. Curve C, what happens here? Uh-oh. Trouble immediately. This vertical line strikes the curve in two different places, so this relation doesn't get to be a function. What this means is when x is -3, y can be either, what is that, like 2 point something or minus 2 point something. Functions are not allowed to do that. They have to give you only one y result for every x you throw at them. So C is not 1 to 1, which means C is not a function. And D, you can see this is going to happen again. That line strikes the curve twice, so it fails instantly. It's not a function. That means when x is 1, the value of y can be either +1 there or -1 there. So no, it's not 1 to 1. No, it's not a function. Now, this middle thing is an odd question. They say for each output value, is there only one input? That means for every y value, is there only a single x? Well, if we try that out, I'm just picking a y value here as an example. This would be y equals 3. When you do that, you notice we hit the curve here at about -3. We also hit the curve over here at +3. Right? This means when y equals 3, x can be either 3 or -3. So no, there isn't just one input. We have two different inputs connected to that same output, so that would be a false. Why would you ever check this? I'm not sure, but I guess they just want us to practice looking at the curve in different ways. So this one is we're picking an output, a y value, and checking how many inputs correspond to it. This one is going to do better. This one, if you look at certain y values, outputs, each of them only hits the curve once, so each of them only corresponds to a single input. So this would be a true. It's like doing a horizontal line test instead of the usual vertical line test. For curve C, you can see immediately there's two hits. This means we have a y value that connects to two different x's. So that one's a false. And for D, just once, just once, just once, just once, just once, just once, just once. So D is a true. D is for each output, as in y value, there is only one input. So middle row, not a lot of reason to care about that. Don't worry about it terribly much. These are a big deal because these tell you, along with the vertical line test, whether you have a function or not.